Welcome back. So in the last video we saw plotting a scatter plot or a figure directly from our car sales data frame. We also saw making a line plot and doing a little bit of data manipulation, like adding a date column and creating a total sales column using the cum-sum function. But how about we look at a few different other kinds of plots from our data frames? How about a bar graph? Yeah, that's a good idea. Let's make some data actually, because we want to just keep practicing all these different types of ways of plotting, creating data, and just seeing as many different examples as we can. So we'll create X variable here. We'll go turn it into a data frame. So we want df equals pd.dataframe. X columns equals, we'll keep it nice and simple. We'll just go A, B, C, D. Wonderful. And now we'll have a look at our data frame. Nice and simple. So we've got some random values here between 0 and 1, it looks like, and 4 columns that are just simple A, B, C, D. Now to get a bar graph, we can do, well, there's one way we can do it, .plot.bar. This is our df here. This is our data frame, and this is just saying, hey, df.plot, make it a bar graph. Let's see what this turns out to be. Wonderful. So this has got a legend here with A, B, C, D, and then we've got the different values for each different row. So this is row 0. We can see A is 0.06, so it's fairly low here, but D is 0.95, so it's right up and high. That's an easy way to make a bar graph using a Pandas data frame and a few different columns. How about we do it a different way? Let's go, because again, there's always many different ways to do the same thing with these libraries that we've been looking at. So go df.plot. Remember how with our scatter graph, we had this kind parameter? Well, you can do the same with a bar graph. Kind equals bar. Put the semicolon at the end. We get the exact same plot. These are two different ways that you can plot a bar graph. You can also change the kind variable here. Which one should you use? It's personal preference, but to be honest, I kind of flip back and forth depending on what kind of graph I'm making. But I'm just showing you this so you've got an idea. If you see these two out in the wild somewhere, you know they're really just doing the same thing. What about next? Let's use our actual data, right? So that was a dummy plot. Let's use the car sales data frame and make a bar graph. We want car sales. Let's view it again. Always good to view your data frames. This is the kind of workflow you'll be going through when you're creating visualizations, is you'll be checking your data frame, making a visualization, checking your data frame, making a visualization, and just keep jumping back and forth. So never be afraid, especially when you're working through the start of a project, to just keep writing code, keep trying to understand your data. So we want car sales dot plot. Maybe we plot the odometer versus the make in a bar graph. We can see that maybe the make will be the X. So we'll have make along the bottom and then odometer as the Y. So let's see what that turns out to be. Equals X make. And then we want Y equals odometer. Ooh, typos. KM. Beautiful. Kind equals bar. There we go. We can see we've got our rows here across the bottom. We've got different makes. Toyota, that's how many kilometers are on the odometer. Honda, that's how many kilometers are on this example. What a bit of an extension might be is to group these together to figure out what the average odometer reading is for each different make. That would be something like consolidating cars of the same make and then averaging what their odometer is. So maybe that's a little bit of a practice that you could try to create an extra column over here or something like that. But let's move on to another type of plot that we've seen before. How about histograms? Histograms are great for visualizing distributions. So that's just the spread of data. So we got, of course, there's many different ways to do it. So we got car sales, odometer. We want to visualize the distribution of the odometer. Plot.hist, this is just exactly like we saw before with plot.bar, but now we're doing hist. Hist is short for histogram. So we'll have a look at this. Okay, so that's the spread of our data. This is that kind of that normal distribution curve around this sort of range, 25,000 to 100,000. Then we got a few here which are a little bit outside that normal curve here. So this might be considered an outlier because of how high it is. And if we come back to our table, our data frame, we can kind of see that this Nissan, which is this one here, has 200,000 kilometers on its odometer, versus the rest of these are barely scratching towards 100. So that kind of makes sense intuitively just looking at this. But you could imagine if we had maybe 1,000 more cars with all different ranges of kilometers, most of them would probably appear in this range if they were similar distribution to what we've got here. Now, what's another way of doing it? So if we go car sales, we'll make the same graph here. Odometer, km, beautiful. We'll go plot, we're going to use the kind parameter here. Kind equals hist, and then we'll do it there. So same graph, just a little bit different here. We've used the kind parameter rather than just the .hist method. So one of the advantages of using the .hist, it has a little parameter here called bins. Now bins by default is 10. So this is, if you're wondering what a bin is, it's these columns here. What a histogram plot does is it takes the spread of data here and then buckets them into bins. So we got here 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is by default 10 bins. If your data doesn't fit into 10 different evenly sized bins, it might adjust the size here. But we can do that manually by passing a different value to hist to the bins parameter. So let's see that in action. Let's go .plot.hist. We're going to change bins. Let's do 20. We'll double it up. Okay, so we can see we've kind of missed that curve there. Now, what is the most ideal value for bins? It's kind of like an exploration. That's a lot of what data science and machine learning is. It's kind of just trying things out and seeing what works. So these don't really look that great. I think 10 is actually probably one of the best values. 10 is probably all right. Well, we do have only 10 samples. Now, what are you looking for here? You're looking for a big curve, like, remember how we looked at the normal distribution? You want to try and find something like this with your histograms, a curve like this. If you can't find exact curve because your data doesn't fit this exact curve, that's not a problem. It's just about having a different go and figuring out what is the most ideal number of bins for your histograms. All right. So we've seen a histogram, we've seen bar graph, we've seen scatter plots, we've seen line plots on our car sales data set. Let's try do something a little bit similar but with another data set just to make sure that we've kind of got these methods down pat. So in the meantime, have a little bit of a practice, make a bar graph, make a histogram on the car sales data frame, and I'll see you back in the next video. We'll do something similar with another data set.